Assalamualaikum. My name is Amirul Ashraf bin Muhammad Rafi. With my friends Danny Hakim and Irfan Hakim, that was from Group 7, we present about satellite communication. First, I want to present about the application of satellite communication. There are many applications of satellite communication that we can study. First is digital audio broadcasting. Digital audio broadcasting, also known as digital radio and high definition radio, which is analog audio, is converted into a digital signal and transmitted on a signed channel in the AM or FM frequency range. Listener must have a receiver equipment to handle this digital audio broadcasting signal. Some digital audio broadcasting stations provide up to the minute news, sport and weather, or written in a scroll text format on the display. The second application is television broadcasting. This service is that deliver television programming to the viewers by relaying it from a communication satellite orbiting the Earth directly to the viewer location. Satellite television provides a wide range of channels and service. It is usually the only television available in many remote geographic areas without terrestrial television or cable television service. The next application is weather satellite. The weather satellite is a type satellite that is primarily used to monitor the weather and the climate of the Earth. So with the technology, it can gain meteorological or weather information, and the photographs taken by satellite are analyzed for predicting the weather. Other types of environmental information are collected using by weather satellite. After that is vehicle tracking. A vehicle tracking system combines the use of automatic vehicle locating in individual vehicle with software that collects this fleet data for comprehensive picture of vehicle locations. Modern vehicle tracking system commonly use VPS for locating the vehicle, but other type of automatic vehicle location technology can also be used. Vehicle information that can be viewed on electronic maps via the internet or specialized software. Mobile communication is also application for satellite. Mobile communication provide a user with two-way voice or data communication service by using some form of portable wireless technology. Typically, providers of satellite mobile communication use geostationary orbit, medium Earth orbit satellite, or low Earth orbit satellite to relay signal up from a headset or terminal and back down to the ground station, where the signal interface with the public telephone or internet. After that, we have monitoring and research satellite. This is very important to monitor the status of Earth resources such as land and ocean. We can get very important information about crops, lake, river, forest, fire, and so on. With this technology, we also can spot our mineral resources, polluted area, and sources of pollution. This presentation we continue to my friends. That's all from me. Thank you.
Assalamualaikum. My name is Muhammad Daniel Hakim bin Zulkifli. My student number is 2019440174. So now I will share to all of you about the comparisons between the satellite system and the terrestrial microwave system. So first, the terrestrial microwave transmission system have the frequency range from 4 GHz to 6 GHz, and the satellite microwave system, the frequency used in the system is between 11 GHz to 14 GHz. So from here we know that the bandwidth for the satellite system is larger than the terrestrial microwave transmission system, because the frequency used in the satellite system is 3 GHz for the bandwidth and 2 GHz only for the bandwidth at terrestrial system. Then for terrestrial system, attenuation mainly depends on frequency and signal strength, while for the satellite system, attenuation is generally affected by the frequency and power. So basically the difference between these two is the terrestrial system depends on signal strength and satellite system depends on power. So both of it depends frequency too. Then for terrestrial microwave system, the signal requirements make installation moderately difficult, and for the satellite microwave transmission system, the installation of the satellites is extremely tough. So we know that the satellite microwave system have the faster installation compared to the terrestrial microwave system. Then for the terrestrial system, it requires focus signals and line of sight as physical path, while for the satellite system requires the proper alignment of earth station antennas. So the advantage for the satellite system, it can access to wide geographical area. Now we move to the cost. Terrestrial microwave system, it can be inexpensive, but long distance systems are almost costly. And for the satellite system, it is very expensive as cost of a building and launching is very high. So we know that the satellite system is very expensive because for one building only it will cost very high, and for the terrestrial system it depends on the distance about the cost. So we move to the signals. Terrestrial system use the relay tower to extend the signals, while the satellite system using the satellites to expand the signals. So I think that's all from me. Thank you.
Bismillahirrahmanirrahim. My name is Muhammad Irfan Hakim bin Abdul Halim from EE1123BA. I will present about the characteristics of geosynchronous satellites. A geosynchronous satellite is a satellite in geosynchronous orbit with an orbital period the same as the Earth's rotation period. Geosynchronous satellites have the advantage of remaining permanently in the same area of the sky as viewed from particular location on Earth, and so permanently within view of a given ground station. Geosynchronous satellites is a circular orbit placed above the equator at an altitude of 35,786 km. At any inclination, a geosynchronous orbit synchronizes with the rotation of the Earth. More specifically, the time it takes for the Earth to rotate on its axis is 23 hours, 56 minutes and 4.09 seconds, which is the same as a satellite in geosynchronous orbit. If you are an observer on the ground, you would see the satellite as if it's in fixed position without movement. This makes geosynchronous satellites particularly useful for telecommunication and other remote sensing applications. There is a small difference between geosynchronous and geostationary orbits. Geosynchronous is, the name itself suggests, is an orbit which is synchronizes with Earth's rotation to its own axis. This means that the orbital velocity of the satellite is equal to Earth's rotational velocity. Any object placed in this orbit will return to the same point after one sidereal day. This implies for any particular location in the Earth fixed for a certain longitude, the satellite remain in fixed area. Due to orbital confusion, the position is not fixed. It may move north and south and be functional for telecommunication and it be used for the telecommunication. A satellite in geosynchronous orbit can see one spot of the planet almost all of the time. For Earth observation, this allows the satellite to look at how much a region changes over months or years. The drawback is the satellite is limited to a small parcel of ground. If a natural disaster happens elsewhere, for example, the satellite won't be able to move there due to fuel requirement. A geosynchronous orbit allows constant pictures other surveillance of one particular region. That's all for me. Thank you.